Okay, so let's look at this integration. So this the command is to integrate x squared dx on the interval 0, 2. Now what this interval means is it takes it from a indefinite integral to a definite integral. And a definite integral is just when you have these 2 points, the upper limit and the lower limit, okay? Or the upper function and the lower function. So in this case, we can see a 2 and a 0. And what this means is I want to find the area between these 2 points. So 2 and 0. And I placed it in parentheses or brackets. So what this tells me is that if I look at this function over here we have the function x squared, okay? So the function x squared crosses at the origin. It's just a simple parabola. And we can see that we're trying to find the area underneath this function, okay, on my x-axis with this interval. So if it's 0 and 2, we can see the first point it starts calculating is from 0 all the way to 2. And it ends there. And that is what a definite integral is. A definite integral just shows that we want to find the area underneath this function. So we can do that by using integration. First thing you need to do is you need to find the antiderivative of whatever function is given. How do we do that? Well, we simply add 1 to the exponent. So we can see x squared plus 1 is 3. And whatever value is on top there, we place it over 3 or over the same exponent value. So again, we have this x squared. We just add 1 to the exponent. It becomes x to the third. And whatever value is there, you simply place it over 3. So now what do we do with that? Well, with that, we now say we substitute my upper function, okay, my upper limit to the function into that. So it's going to be 2 raised to the third power over 3. That gives me 2.667. Okay, so in this case, we can see, well, it only took the 2. Well, ideally what you want to do is you want to take the upper function or the upper limit of the function and you want to subtract that from the lower limit of the function. But in this case, if I substitute a 0, so if I say 8 over 3 minus 0 over 3, it's just 0, so we don't even have to add it. So we skip that part. So we can then see, well, the area underneath this curve is going to be 2.667, or approximately 2.667 on this given interval. Again, if there's no interval given, this will be my final answer to my indefinite integral. So we're going to add a plus c. Okay, let's look at this next one. Well, this next one, I want to integrate the sine of x plus 4x. So now we have 2 separate functions. Okay. We have the sine of x plus 4 of x. So first things first, we need to find the antiderivative of this function. Okay, the antiderivative of this integral. And how we can do that is we know the antiderivative of sine x is cosine x. And the antiderivative of 4x will be 2x squared. So how do we get that 2x squared? Well, currently this is x raised to the first power. So we plus 1. So that gives me x raised to the 2. We place that over the exponent, which is 2. And then we have 2 divided by 2, or 2 divided by 4, which is 2x squared. Okay, now, here's what we're going to do now. In this situation, we can see that we have negative 3 plus 8 pi squared plus cosine 1. Okay, so what does this mean? Well, this means that I'm going to say 2x, 2 times 2 pi. Okay, 2 times 2 pi squared minus cosine pi. Now, cosine pi is simply cosine 180. And cosine 180 gives me 1. Okay. And then we need to subtract that from the lower limit. So in this case, we have 2 raised to the 1. So that gives me 2. Okay. So we have 2 minus 1. Okay, which is pretty much just 1. And then when we input the values, so you have this the f of b minus the f of a to find the area. And when we plug all of that in, we can see now, well, the interval is just between 1 and 2 pi. So here I have a 1, To find out how to do these calculations, I made a different video on exactly how to calculate these areas. But this is just the representation or the mathematical representation of what's happening. So in this case, our interval is between 1 and 2 pi. So we can see, well, there's my first point, there's the 1 on my closed interval, a 1, and my final point is 2 pi. 2 pi I can find by 3.14 multiply 2. That gives me a little bit greater than 6. And pretty much just what we did is, again, we just calculated the area underneath this curve. And then that should give me my final answer. Since we're working with area, we always want to give our answer, final answer in unit squared. Okay, unit squared. And for the indefinite integral, if we have no values, where we have 2 pi and 1, this will be my final answer. 2x squared minus cosine x, as we just found the antiderivative of this given function. And then plus dx, or plus the constant which is usually be plus c. So again, in this case, all we do is we take the upper limit minus the lower limit. Okay, so we're going to take the antiderivative, we're going to substitute 2 pi and 2 pi. Oh, excuse me, it's going to be negative 360. Sorry about that. And for the next one, we're going to say, well, 2 pi squared minus cosine 2 pi, and we're going to place that into one big parenthesis or squared brackets, and we're going to subtract it from the lower limit, which is going to be 2 times 1. In this case, we're just substituting the x with a 1 now. So it's going to be 2 times 1 squared minus cosine 1. And when we type that on the calculator, it should give me this final answer. So I'll quickly head over to Desmos to show you what I mean. So the answer we got on Wolfram Alpha was 76.496 or 497. So if I head over to Desmos, notice that my answer varies a little bit since they rounded off. But notice what I did here. Notice that we have the upper limit of the function. This is what I mean, right? If we found the antiderivative, we saw that it's 2x squared minus cosine x. And then we're going to subtract this from the lower limit. The lower limit was the same thing, but we're just replacing the x coordinates with what's on top of the integral and what's below the integral. Below the integral becomes negative. Okay. So notice what happens if I put in 2 pi. I mean, we get the same answer, but you need to be very careful, because on certain calculators you have two modes. You have a mode that is in M and a mode that is in R, which is radians. Okay, so in radians on your Casio calculator, you will find the exact same answer. But if your calculator is in the M mode, you'll find some extremely small number. So my advice would be, in most cases, to avoid any confusion, is just to change this to 360, since 2 pi relates to 360, okay, through a mathematical conversion by multiplying 2 pi with 180 over pi, right? That's to go from radians to degrees. But either way, we can see, well, the answers correspond. So this is taking the upper limit of the function and subtracting it from the lower limit of the function. And that's how we find the area underneath a curve. But first things first, you need to find the antiderivative of the function, and therefore we can solve the area.